a disk, then we talk about a surface area of pi r squared. If you remember your JHS mathematics, pi r squared for that part or one part of the Earth where the sun's radiation reaches. Then if we assume that the sun's intensity or the sun's energy is S, then the energy that is incident on the Earth by the sun, we can use this equation pi r squared S. So a little bit of physics or equations, but don't worry too much about it. Grab the concept. The energy reflected due to albedo, which I explained earlier on, different colors will reflect different parts of the, or different sun's, amount of sun's radiation, depending on the color. So as the sun is coming in, you saw earlier on through the arrows, some part is reflected back to space or back to the sun, if you want to put it that way. So albedo is the reflectivity of the material. So we have to consider that in this scenario. So then when we put in reflectivity albedo with alpha as the symbol, we now have the energy reflected due to the Earth albedo comes as alpha pi r squared S. So the solar energy absorbed by the Earth. So the sun's coming in, but then we have some reflected. What is left is what is absorbed by the Earth and comes in an equation like this last one, 1 minus alpha in bracket pi r squared. Don't keep it in your head. I'll just recall it in the course of time. So we are using this to arrive at a scenario where we have the major input of energy from the sun to the Earth and the association with global warming and all of that. So you bear with me, you will get to understand. So we consider radiation laws or different natural laws of physics, laws in chemistry, in all this, because they do affect. There are so many laws I didn't put up here. We have a lot of radiation laws, inverse square law, what that says, the further away an object is from the source or from the sun, the less concentrated the sun's radiation will hit that object, which is like normal, logical. This particular law, I brought it up because we're going to use it extensively, is the Stefan Boltzmann's law of radiation. So this law explains that every object gives off radiation as a function of their temperature. So you, human being, you radiate energy, you give off some heat, and you can test this when you are in a room with other people with even air condition on, how the room can get heated up with. So the more you add the people, the more heat you generate in the room from your body, from yourself. So the sun, so the hotter an object is, the more radiation it gives. So the sun's radiation give more heat compared to the Earth, because we know that the Earth is not hot, it's cold. Not cold, but it's just okay at some temperature, relatively colder than the sun. So the sun will give more radiation than the Earth. So this is another law. And we use this equation to explain or express the law. E as the energy or amount of energy or received from the sun is equal to, or for any object anyway, is actually proportional to the fourth power of temperature. And the constant of proportionality is this sigma, that is the Stefan Boltzmann's constant. So there's a value to it. That's an amount of radiation emitted. So the hotter object emits more radiation than colder object, and this is per unit surface area. So we are going to use this equation, E equal to sigma times T to the power 4 in the next few slides. So we have talked about the sun's radiation reaching the earth and how the earth absorbs before I brought in the radiation loss. Now, how much energy does the earth also radiate? For radiation, it's not about part of the body. Every part of the body of any object radiates energy at the same time. There's no blockage to radiation because the radiation passes through anything. So there's no blockage. So the earth radiates energy everywhere around it. And if we assume that the earth's surface is a sphere, then we use the surface of a sphere or the area of a sphere to relate to our story. So the surface area of this surface of the earth will now give 4 pi r squared. This is also dated back in your JHS mathematics. If E is the intensity of energy radiated by the earth, then the energy radiated by the earth will be 4 pi r squared E. And remember, we had defined the E in the previous slide with Stefan Boltzmann's law as E equal to sigma T to the power 4. So the energy radiated by the earth is therefore pi r squared sigma to the T to the power 4. I hope this is not too difficult to accept. Okay, now from the various atmospheric laws, consideration of all the natural laws, have you heard of the law of energy, that energy cannot be created or destroyed? You've heard of that one, that it can only be converted from one form to the other. So now we say that the amount of energy absorbed by the earth is the same amount that is radiated by the earth. So we cannot create new energy. Energy from the sun absorbed by the earth is the same amount that is radiated by the earth. That is, if you want to assume that the earth is a black box, what comes in is what goes out. Then we can equate the two equations. So remember the solar energy absorbed by the earth that we did earlier on is here, just reminding you here. When we put the two equations together, this very first one and the one we just received or we just got from Stefan Boltzmann's equation, so that is the energy radiated by the earth, we cancel the common terms. We end up having an equation like this. So we put the temperature as the subject of the equation. We get not square root, but the fourth root of the sun's intensity, the intensity of the sun S. So this is the radiation from the sun absorbed by the earth. And 1 minus alpha all divided by 4 sigma. So we just change subject here to get this equation. If you put all the constant that we know, like solar constants, we have a value for it. Albedo of the earth, we have a value for it. And the Stefan Boltzmann's constants, we have a value for it. If you put all these things in this equation with your calculator, you have a value in Kelvin. When in degrees Kelvin, when you convert it, you get a temperature of negative 18 degrees Celsius. This is supposed to be the average temperature of the earth because what comes in is what goes out, and we have just calculated it here. But the average observed temperature, the average temperature of the earth that is measured, that is observed, is actually about 15 degrees Celsius. So why is it that we use the laws as much as possible, but we are not getting what is measured? So we calculate to get negative 18 degrees Celsius, but then what is measured is 15 degrees Celsius, positive 15 degrees Celsius. And the question is, this 18 degrees Celsius is a world without atmosphere. So if you remember the narration, we did not consider how the solar radiation is absorbed or reflected by the atmospheric component and how the terrestrial radiation, the radiation from the Earth, interacts with the atmosphere. We did not consider that. We followed the laws, but we ignored the issue or the influence of the atmosphere. So if we're not having atmosphere, the average temperature of the Earth would be negative 18 degrees Celsius, much, much colder than today. And life will not survive it for an average temperature of negative degrees Celsius, which means that the atmosphere is important. It's the same atmosphere that we have the greenhouse gases. And so when we include the greenhouse effects, which I'm sure you learned it through the various models that you did online, and I'll ask one of you to tell me what greenhouse effect is. Are you there? Who can say what greenhouse effect is? Any hand up?
No, there is no hand up.
Nobody wants to talk.
Somebody responded in the chat. Jacqueline.
Okay, can you read that?
Can I?
Please, can I speak?
Yes.
So the greenhouse effect is the process by which the earth traps heat.
Did we get you right?
Bro, she said the greenhouse effect is the process by which the earth traps heat. That's what she said.
Yes.
And Gideon and Felix to raise their hand. Gideon, can you please go on? Gideon, Felix, if you are ready, please speak.
Okay. Is it talking?
Hello, sir.
Yeah, go ahead.
Hello, sir. Please, can you hear me?
We can hear you.
Hello.
Go on.
Okay. Okay, so greenhouse effect is the natural warming of the earth, and then it has to do with when the heat is trapped in the atmosphere of the earth, and then it releases certain gases into the atmosphere.
Okay, I see many hands up, but we need to continue. So it's maybe natural or not natural. So you don't need to use the word natural. You can just say the explanation or the definition without bringing in natural.
Okay,
Is it okay?
thank you very much.
Okay, so let's continue. So it's the effect where we have the greenhouse gases in the atmosphere, and they trap the terrestrial radiation, that is the earth radiating out of the earth. So it's supposed to get out to space, but the radiation get trapped by these gases in the atmosphere, and then we call it greenhouse effect. So we're trying to explain all that I have said earlier on the explaining the science behind the warming with a simple model. So here is what comes in. That's what we have learned earlier on. The A is the alpha, the albedo. And solar constants, it changes, though it's called constant, but it changes depending on the activity of the sun. Then the albedo, so the surface also can change depending on if you are planting more trees, if you are cutting trees and building houses, if you are building roads, the albedo can also change for Earth. And this is what goes out for the terrestrial radiation. So the radiation of the Earth that goes out. So here we have included the epsilon, which is the greenhouse effect. So we have to consider the greenhouse gases in the atmosphere. With that, we expect to get a temperature of about 15 degrees Celsius as what is measured. But in doing the model, we have to consider the climate system, which is so complex that we have so many processes happening in the atmosphere at the same time. Every component of the Earth and of the atmosphere affects the climate system one way or the other. So we have to consider all of that in trying to understand the model. So the solution here is to make input of all these variables plus the greenhouse effect, which we put it as a term here, 0.61. And then we expect to get our temperature of about 15 degrees Celsius, but here you see 16 degrees Celsius, it's about the same. Even with global warming, we have gone beyond 16 degrees Celsius now, and I will explain. So this is the greenhouse effect. The more we have the greenhouse gases in the atmosphere, the more warming we expect the Earth to have, which means that the more this 16 degrees Celsius now will change to a higher value. So the more we have the greenhouse gases in the atmosphere, the more we expect that to change. And one important greenhouse gases, or two of them, is methane and carbon dioxide. And we are getting increasing concentration of these important greenhouse gases in the atmosphere. So these are natural occurring, but now we human beings are adding. So we say man is modifying the concentrations of carbon dioxide and methane. And we are doing that through the burning of fossil fuel, especially the rearing of livestock, waste incineration, and other practices. We are adding or modifying the concentration of these greenhouse gases in the atmosphere. So the natural one should just warm the Earth and make the Earth average temperature as comfortable as we were. But now as we are adding through our various activities to the concentration of these gases in the atmosphere, that is where the warming has come. That is where the globe is warming unprecedentedly. So now the carbon dioxide concentration are higher than any time in the last 400 years. We can quote it in different ways, but the key point is that because we are adding or increasing the concentrations of these greenhouse gases, the temperatures are warming. The Earth is becoming warmer than it's supposed to warm. And we can see from the various measurements that here you can see this is carbon dioxide measured values from 1960 or before till most recent years. And the level of inclusion or concentration of carbon dioxide that is in the current years showing up in the atmosphere is worrying. And I will use another graph to explain. So in the 20th century, the emissions were still relatively low until the mid years. So in 1950, the world emitted 6 billion tons of carbon dioxide. So now the years and figures, the world emitted 6 billion tons of carbon dioxide. By 1990, this value had quadrupled. So this is about 40 years. And the value had quadrupled, reaching more than 22 billion tons. So from 6 billion to 22 billion in 40 years. From 1990 to now, we have emission that has grown rapidly, and we emit 34 billion tons each year. So in 40 years, we reached 22 billion tons. Now we emit 34 billion every year. And this is a matter of concern. And this is only from fossil fuel. This is only carbon dioxide from fossil fuel. We also have methane and carbon dioxide from agricultural practices, especially methane from rearing of livestock, cattle, cows, goats, and sheep, and all of that. We also emit a lot of methane from that. And all of these go into the atmosphere and keeps the atmosphere warmer than it's supposed to be. So why do we want to, or why do we focus on methane and carbon dioxide all the time or most of the time? So if not destroyed in the troposphere or reacted with other gases in the atmosphere, methane can last for 12 years in the atmosphere. So if they don't, the CH4 don't get reaction and change to other gases, it can stay in the atmosphere for about 12 years. Carbon dioxide can last much longer, between 300 to 1,000 years, if we add it in the atmosphere. So if the carbon dioxide also doesn't get reacted with other gases and change to other forms for a short-lived, then it stays between 300 to 1,000 years, which means that any mitigation effort we do now, even for carbon dioxide, not to add more to the atmosphere, the carbon dioxide that exists now will continue to be there and will continue to cause warming for about 300 to 1,000 years. That is what it means. There are other greenhouse gases, but most of them are we call them short-lived climate pollutants or short-lived pollutants of the atmosphere. So the others are also there. They cause warming, but they stay shorter periods than 12 years or 300 years. So the other gases in the atmosphere, they also get reacted like CO2, CO, the carbon monoxide, easily gets reacted with other gases in the atmosphere than carbon dioxide. So the rising, for me, is not surprising because we can do a bit of chemistry here. Because for every gram of fossil fuel we use, we produce 3 grams of carbon dioxide in the atmosphere. So if you buy fuel in your car and you drive, every gram of that fossil fuel, you produce 3 grams of carbon dioxide. This is chemistry, and we get the energy out through combustion and the carbon from the hydrocarbons. So whilst the fossil fuel is burning, you get energy to drive the car. Then the carbon comes out into the atmosphere. So we get oxygen that also goes off. So we have oxygen reacting with methane to give us carbon dioxide and water. If you see some people have their car, locally, if you look at their exhausts, you see some water dripping slowly from there. It's the burning of the fossil fuel. So carbon dioxide will come out through the exhausts, and then the water can also drip out. How much more do we expect? We have 100 parts per million increase over this short period. So the carbon dioxide increase is absolutely expected so long as we are using fossil fuel to power a lot of our things. We even use it to produce energy. Apart from driving, we use it in our factories and all of that to generate energy. But at the end, we add carbon dioxide in the atmosphere. So for climate change, we are all responsible. So if you are benefiting from the burning of fossil fuel, if you fly in planes, if you are driving car, if you are being driven in a car, if you live in a house, you are all contributing to the warming of the atmosphere. But how much we have each contributed depends on our level of richness, and the rich countries have contributed more. So our lifestyle, our consumption patterns are all are variables to our contribution to this global warming. So the rich are more responsible in contributing to this, because the richer you are, the more you use resources around you, including fossil fuel. However, the poor is the greatest victim of climate change. So whilst the poor contributes less to this problem, the poor actually are greatest victim, because the poor also doesn't have the adaptive capacity, the resources to adapt to the climate change. We call it ethical dilemma, where you contribute less but gets more problem based on the same thing. So our options are to mitigate, to reduce these greenhouse gases in the atmosphere, reduce adding more, and also to adapt, because currently the impact of climate change is happening, and we have to adapt to what is going on. So we have to prepare different ways of adaptation. If it gets too warm, you want to live in air condition and also add more to the greenhouse gases. You want to live in a house that is more cooling than normal. During heat waves period, you want to stay indoors than to go out. So different ways of adapting. Where we have flooding, you want to dredge trenches for water to pass on runoff or something. There are different ways we are all adapting. We have adaptation at personal level, at regional level, at the global level. And all of these efforts are for us to still live comfortably within the sphere or the space where we have created the warming. I say we have failed on the Paris Agreement, because if we have agreed in 2015, and internationally we have all countries that are members of the United Nations have signed up to on the Paris Agreement to help reduce global warming. We have failed because even the nationally determined contributions, which we say NDCs, suggest these reductions, but even if they are fully implemented, it's not likely that the global warming will go below 2 degrees Celsius. This is 2024. As at 2023, we have reached 1.36. In the Paris Agreement is talking about 1.5 degrees Celsius. And we have to get this before 2050. This is 2024. And we are already 1.36. So for me, I say we have failed at this. And if we continue to allow the warming to move at the rates at which it is going, we may be reaching the climate tipping point, which has become a growing concern. And I'll use this to just an animation to show the tipping point. So this is the earth warming on the inclined plane. So as it's going up, it's warming.
Up. Before the pivot is reached, the ball can come back down, but once you pass the tipping.
So at every point on the inclined plane, the earth can get back to its normal states of the normal conditions, the climate conditions that we are in. At every point on the inclined plane, this is natural. At every point, it can get back. But once it gets to this point where we call the tipping point, and goes a little bit over, then the earth will run into a new state. We cannot have
ball
control
carries on
and
speeds up without any further pushing.
So before this point, on this point, this is where we don't want to get there, but we are almost at this point, because beyond this point, a little push.
Eventually, the ball comes to rest in a new steady state, and it is more difficult for it to return.
So at that point where it has overrun the tipping point, the earth will run into a new state where we cannot predict and understand the behavior of the earth. And I use this boiling frog fable to explain the situation that we are in, or we find ourselves, and compare it with COVID-19. So when you put a live frog in a boiling water, you push it in, it will jump out immediately because it's just too hot for it. And that is the situation we found ourselves during COVID-19. The whole world woke up to finding solutions to COVID-19 because it came like a hot water on us. So we jumped out immediately from it, COVID-19. 2019, 2020, we worked so hard. The whole world complied by instructions, vaccines, travel, all the restrictions. We did that and we are able to get back normally, even though it's still lingering around. It's not as pandemic as it used to be. But then when you put the same frog, the same live frog in water of normal condition, and you apply heat slowly underneath the water, it will try to adjust to the temperature slowly. Oh, I can adjust. I'll use fan. I'll use air condition when it is flooding. I'll use big cars. Instead of walking, I'll use umbrella. I won't walk in the rain. We are adjusting slowly in the boiling water with all the consequences that are coming. We are adjusting slowly until these frogs or the frog got boiled in the water and didn't have the energy to jump out. I see that the more we try to adjust to the warming, the more dangerous we are putting ourselves in. So the danger we are putting ourselves in is allowing this water to boil, allowing global warming to continue, and we only adjusting and not doing as much as we have to do. So for me, I say our options are to stop global warming. How do we do it? One, we have to stop the use of fossil fuel, and now, which means that we have to produce electricity from other sources other than fossil fuel. Like we can go into nuclear energy. For countries that are comfortable, they are doing that already. Most developed countries are into nuclear energy, although they still use fossil fuel for other energy input or energy sources. Most of them have nuclear energy. We should start driving electric cars so we don't put fossil fuel in our cars. If we can build our technology to where we can fly solar-powered electric planes, we should do that. And imagine a world where we stop using plastics. It's going to be very difficult for us, but it's something, if you want to be ambitious, we go through all of these and many more actions that we have to be more ambitious in doing. Other ways which you can explore, although new and have a lot of ethical issues around it or questions around it not answered, is what we say remove the carbon dioxide in the atmosphere. So we say carbon dioxide removal. There are techniques that scientists are coming up to remove the carbon dioxide that exists in the atmosphere. The question of how much to remove and where and all of those things are also there to answer. Or we do solar radiation modification, so that the picture here shows that we can provide aerosols in the atmosphere or mirrors that can reflect the sun's energy back to space, so that the amount of sun's energy that we get into the sun that helps with the warming of the earth will reduce, so that we can keep the earth cooler than it is now. So there are scientific techniques that is being explored, but then we have to do all of them and not leave any other. So whilst we are trying to remove carbon dioxide in the atmosphere, it doesn't mean we should continue to use fossil fuel. We can stop fossil fuel and be more ambitious in our actions. So these are a few that I plan to share with us. And before any questions, I'll also want to introduce to you that in this month of September, the Department of Physics will be running a climate data analysis course and modeling course. And if you're interested, you should be on the lookout for a call for application on this. And then we also will be running biogas production technology training in the following month, October. So look out for this announcement, and that is the end of my presentation. Thank you. We'll wait for questions. Terry.
Thank you, Prof. And in the course of your presentation, John Quayson asked a question. He said, can we say global warming is under climate change?
Okay, I'll explain. So I explained that the globe is, so global warming means that, so the term warming is relative, right? It means that it was once cold and then it's now warm. So that means there's a change. It means there's a change. But so global warming itself is climate change if it is significant. But then if you say under, it's contextual, because global warming is also causing other variables in the atmosphere to change. So when we have temperatures increasing, it affects wind. It affects wind speed and wind pattern. It affects humidity. It affects precipitation. It affects, so precipitation includes snow, it includes ice, it includes rainfall and all of that. So it affects how these ones also fall or behave on Earth. So I don't know how you would now put it, if it is under or it's...
Oh, okay, thank you, Prof. And then another question in the chat. He said there is a lot of methane trapped into the atmosphere, which eventually causes global warming. Can we not use this methane as for sort of converting it to something else?
That is why we are doing a course like this. We need innovators. We need to have solutions. So if you are able to think through, come up with ways we can trap the methane in the atmosphere and use it as fuel, bingo. We are using hydrogen as fuel, even from water for, what's the name of this fuel? Yeah, hydrogen fuel from water. It's called, it's hydrogen fuel, but fuel cell, yes, fuel cell. That's hydrogen, so water as fuel, but then the hydrogen part of water as fuel. It's an innovation somebody or a group of people came up with. It has not been tested fully, and some are using them and all of that. So if yours is to come up with ways, yes, we can trap methane, why not? The reason we are doing this course, so this is the training for you to now become innovators. In that's another 1 month section or 3 month section where you have the incubation where you come up with these ideas. We'll be happy to hear solutions from you, the youth. I don't know it as at now.
Thank you, Prof. Jacqueline Cranton's hand is up. Please ask your question.
Okay, thank you. Please, my question is, what is the average amount of carbon dioxide needed to be in the atmosphere? And is there any form of measurement on it? Because you didn't mention it.
You are right. So our reference year is normally in the 1880. The amount of carbon dioxide in the atmosphere, we say it has increased. So it increased slowly. So any amount that was in the atmosphere in 1880 was keeping the average temperature at 15 degrees Celsius. But then now it's gone up to 16.36 degrees Celsius. So if we attribute all of this warming to these greenhouse gases in the atmosphere, most of them are carbon. So CH4, CO2, but all of them, most of the CO, most of them are carbon, though we have nitrous oxide and all of that also in the atmosphere. So, which means that we can do, I've not done the calculation, we can check from the graphs let's say I'm going up to the graphs. We can check from the graphs what was the value in just here. So these are anomalies. Let's see. Where is carbon dioxide? Okay, here. This is 1750, 1800. So this is 0 tons, 1850. So all of this time, we didn't have fossil fuel addition of or source of carbon dioxide in the atmosphere. So these were the times we had the naturally occurring carbon dioxide in the atmosphere until 1850 going up, where we had the input of carbon dioxide from fossil fuel adding up. So before then, it says growth in emission was still relatively slow until the mid-20th century. In 1950, the world emitted 6 billion. I don't know the exact amount that's naturally occurring. I mean, we can have a range, which should be not, just trying to get a figure. So this is 1960. This is about 320 parts per million in volume. Anything below 320 parts per million of carbon dioxide should be fine, but now it's going up, so. Yep.
Okay, well answered. Thank you.
Terry, will you call those with hands up?
Okay, thank you. Wisdom, please ask your question.
All right. Thank you very much for the opportunity. And so you made mention that the rearing of livestock contributes to increasing in greenhouse gases. So I think the livestock sector actually forms a great version of the agricultural sector, not only in Ghana, but in major parts of the world. So I want to find out if there are any specific processes through which probably the rearing of the livestock helps to the increase of the greenhouse gases. For instance, as a soil chemistry student, I got to know that the application of nitrogen fertilizers to pastures that are being used to feed this kind of livestock, sometimes through the by decomposition or breakdown of the fertilizers, nitrous oxide is being released, which is a major component of a greenhouse gas, but in the form of methane. Which specific processes do this okay? Probably some of us could try to look at that aspect to try and bring ideas to if we can help minimize that. Thank you.
Okay, thank you. So in relation to that, Gifty is asking, are we supposed to stop eating meat and the rearing of livestock because it releases methane into the atmosphere? So some people are vegetarian because of this, so they don't want to contribute to the production of livestock. If you want to choose that path, I mean, well enough, it cuts down the demand on livestock and the production will go down. The process in which livestock releases or give off methane into the atmosphere is through the digestion of feeds that we provide for this livestock. So they release a lot of gases through the digestion or digestive process. And so if they get to eat quality food, it's same as humans. If you eat quality food, you don't give off so much of gases, you don't fat much. But then if the quality of food is not as good, as it's supposed to be. You give off the fat. So the same with these cattle and livestock, they fat a lot if they don't get quality of feed to eat. So the quality of feed for these animals are very important to curtail the addition of methane in the atmosphere. That is one key thing for methane.
Thank you,
other
Prof. And
there
there's
are some questions in the chats.
yes, somebody.
Okay, but if there's a hand up, we can.
Okay, Gifty, please go on and ask your question.
Okay, thank you very much, Prof. And thank you, the moderator. I think you're very articulate at what you do, Prof. I really enjoyed your presentation. So my question has to do with when you said even in the absence of human being on Earth, there will still be climate change. And so that informed me that it could be that it's human activities that actually contribute to these significant changes in climatic conditions. But then I was wondering if it's human activities that causes these significant changes. Is it not the case that natural disasters like earthquake, like flooding and all of that, is it that they can't also cause the earth to, so that we can have some form of change naturally? Or is it that they are not significant enough such that it can cause changes in the atmosphere, even in the absence of humans on Earth? Can it not be the case, or they are not significant enough? I'm talking about earthquake and flood and other natural phenomena that causes change.
I will explain. Yeah. So you can use your body as an example, your natural self. So the earth is a natural system which corrects itself and always try to get to a balance all the time. So if there are not enough naturally occurring greenhouse gases in the atmosphere, there will be earthquake. There'll be other things that the earth itself will do for it to get to a balance. So the earthquake, they happen naturally, right? When earthquake happens or occurs, we get greenhouse gases pumped into the atmosphere. And then if it gets too much, there are also ways the earth itself try to correct. But what the earth is struggling about is our addition of the greenhouse gases in the atmosphere, which is not natural for the earth to contain. So I said we can use you as an example. If in your normal self, you can have a life without even a headache, but when you stress yourself so much, then you have a headache. If you drink enough water and you sleep, the headache can go without taking any drug. But if it gets so much or too intense on you, you may want to take a PMOL or any analgesics for you to feel better. So just drinking so much water and sleeping may not solve your problem, even though they are natural processes to your natural self. But you may need to do more by taking medication to get back to normal so that you don't have the headache again. So that is the situation we are in for the earth. We have given it too much problems that we need to be more ambitious in solving it. So if we have to look for PMOL to give to the earth, we have to do it so that the earth will get back to its normal state. That is the whole essence or idea. So there are natural contributions and there's human also adding up. But then our addition is causing the earth to behave in a way that, of course, we say is not natural. Okay.
Okay, thank you very much.
Thank you, Prof. Now, Abby has an interesting question in the Q&A session. She's asking that, is it okay to say that there is a way that the atmosphere can rather adapt to our living instead of we adapting to its conditions? Because if there are no alternate solutions in the world, can we come up with a way to change the atmosphere and make it to adapt to us?
YCLIP, bring out the solutions. So I don't know how we will cause the atmosphere or the earth to adapt to our changes or our behavior. If you have those ways, please come up with them other than we adapting. In fact, if you have that, it will be bingo for us. Yeah, so come up with those solutions. Then
All right,
I see Kojo also asked a question that if you can, somebody said, can we say that increasing the albedo of Earth can help climate change positively? And is there a way we can increase the albedo of Earth? Okay, so the idea for solar radiation modification or management is simply increasing the albedo of the atmosphere so that we get a lot of the sun's radiation reflected back to space, and then that will also reduce warming. So yes, it's done. It can be done. But then we have not practicalized it. It's still a research phase that is technique that people are exploring, but it's at the research phase. It's not yet deployed.
all right. Thank you, Prof. I think we will take the last question from
Excuse me. Excuse me. Can I be the one to take the last question?
What is your name?
Okay.
Please go on.
Thank you very much.
There are
Okay,
some in the chat. I'll read them. So those that are already in the chat, we'll read them. But then those who want to talk should go ahead.
Okay. Thank you very much for this opportunity. In the beginning of this whole presentation, you mentioned on the Article 6 of the Paris Agreement. Am I correct?
Yeah, go ahead.
Okay. Please. So I'd like to know, in the beginning, you mentioned your affiliations to organizations here in Ghana pertaining to climate change. And I wanted to ask, are there direct means to which young startups can access funds from all the investments pouring into Ghana's economy for young startups like us who are here today to be able to face these issues with our solutions?
Okay, so if I get you right, so my position is at the UN level. It's not like Ghana. I represent Africa on IPCC, which is the UN institution that looks at the climate change issue around the world. And your question specifically on funding for startups. So there's no clear-cut funding from the IPCC. The IPCC does the research, but we can give recommendations to organizations that give or provide funding for startups and any other thing that's related to climate change. However, you need to it's not like just there for young people to just go for, but it has to come through an innovation, an idea that will help solve these problems or challenges that you're talking about. So if you have such a vehicle, one of the vehicles to use is the YCLIP. Once you go through this kind of training and then you have the innovation and you put it up, YCLIP will bring you the source, the necessary funding to implement the plan. But if it is ordinarily on the fact that you are being affected by climate change and you should be compensated, we are not there yet. Even the compensations are coming from the global scale to country level. Like we have the climate change fund, which should be assessed by countries and it's another topic altogether. The climate funds are even difficult to assess and all of those. It's another topic altogether. But we have also the adaptation fund, and these are used by government to implement actions, climate actions towards adaptations. There are different types of funding, but it depends on what you're doing and where you're doing it.
Okay, thank you very much.
Okay. There's a question in the chat that says, can we say land use patterns are also factored directly affecting climate? Example, loss of our forests are being lost to bare land, which eventually turns into desert. Exactly that. So Nana Kwame, the thing is, when we clear the land and we lose the forest, we have bare land, it changes the albedo effects of the earth. So reflectivity becomes different. That is one. Land use pattern is also adding to greenhouse gases in the atmosphere. And the most contribution of greenhouse gases from Africa is on land use change. So definitely we have that effect. So planting more trees will help. That is it. So exactly as you have put it, we don't need to lose our forests. It's important to have our forests to remove the carbon dioxide in the atmosphere. Yeah. Any other thing? So there's another one.
Prof, I
Sule, no.
think there are more hands up, so I will open the form again to take the questions so that we can
Answer
proceed.
them.
Yeah, so
Okay, so whilst at it, I'm reading. We all know cars produces fumes which contribute to GHG, greenhouse gas emission, but I'm lost. But sometimes the fumes some cars produce are too much. So my question is, what is the government doing about this? Because I don't see any effective policy checking these things. Yeah, it's difficult to say, but one thing that we know government of Ghana especially has pursued is to add more levy on importation of old cars that are more than 10 years. When you want to bring it in, you pay a lot more of those kind of things. Yeah, that's it. Okay, so we can take the questions and then we'll see the answers.
Hello.
yeah, please go on.
Yes. We know that the CO2 compound is the compound with the highest how do you call it lifespan. So I wanted to ask, are there any organizations that will oppose the bioengineering of certain plant species to foster probably twice the amount of carbon dioxide that plants are normally known to absorb? That's like an innovation.
So there are institutions that are pursuing climate interventions. There are a lot of them, and they are growing as well now. But using crops, so there's one crop that you can use, but then that is also not advisable because the crops are invasive, and so they cover the surface of water. I think they are kind of water lilies type of crops. They are able to take out either methane or carbon dioxide from the atmosphere. But then they cover the water surface, and the water will not also get sunlight. Then the environment, the aqua environment will also get into trouble. Something of the sort.
Yes, but then what if it's on land? and where like what we are doing is we are bioengineering certain plant species that we have studied, and
Yeah.
know that okay, if we alter its genes for it to absorb like the amount of carbon dioxide emissions in the air, it's going to help reduce the amount of CO2 in the stratosphere or in the atmosphere, wherever. I mean, are there organizations that propose these kind of ideas? Because I know that with when it comes to bioengineering, the bioengineering field, I know that there are a lot of regulatory bodies that must authenticate whatever idea you are sort of like bringing on board before it's even out there. Like, are there anybody
Yes.
that may hinder like this idea?
Yeah, so yeah, the organizations that are leading that and actually practicing that. So in Ghana, I know of the GAYO, the Green Youth.
Green Africa Youth Organization.
Green Africa Youth Organization. They are into these different types of climate intervention. So they promote and they train, they do different things in that field as well.
Okay. And one last question. Some years back, I had this idea to like create a device to help reduce the GHGs. So is there like any fund or like investors out there that like invest in ideas of such? So like my idea basically is for like cars and then plants and these heavy duty machines that use fossil fuel. So what the idea basically that absorbs all these emissions, then prevents them from being released into the atmosphere. Are there like any NGOs, bodies, or whatever that like to invest in ideas of such?
It's very difficult to get you through, but
can you hear me?
Idea that you have, right?
Yeah. Can you hear me?
Yes, but it goes like off and on.
Okay. Let me take it again. I'm saying that I had this idea some time ago where the every vehicle on the roads, if we indulge in this idea, every vehicle on the road has this device that the fumes that they are emitting in the exhaust goes into this device, then reacts with the fumes, preventing the fumes from being released into the atmosphere, increasing the amount of GHGs we have in the atmosphere. So my question is, are there like any bodies or investors out there that would like love to invest in such an idea?
So is it a prototype machine or it's been tested and?
Well, it's in theory. It's
in theory.
Yeah.
I see.
And then it's something that will involve money and then experts in
yeah, definitely.
And auto field. Yeah. So, and also chemists. The idea largely depends on like chemistry. So I just wanted to know if like maybe I can get any help.
Yeah, definitely bring it on board, and then beyond this training where you go into your innovation hubs, you can, if that will be your project, once you pitch it well, we can look at how to support that. I mean, definitely.
Okay, so can I come by the physics department?
Sure. You can.
Oh, okay.
Get in touch with Terry, and then we take it from there. Okay, thank you.
All right then, Prof, thank you for such a wonderful presentation.
Thank you.
My key takeaway was that climate change is a natural part of the Earth's natural variation. At least for that, I've learned something today. And I've also learned that the Earth radiates energy in the minute that direction. That is why there is a 4 pi r square attached to the by equation. And then, since we've exhausted most of the time, we are going to ask you to drop your key takeaways in the WhatsApp group. And before we file out, I would like all of you to turn on your cameras so that we take a group photo, a selfie for. So all of you.
I see that there are still many questions that have been dropped here. We can put the answers also on your WhatsApp chats, and then it could benefit all of you. But let me say thank you to Lucas. If he's here, I didn't acknowledge him earlier on. Thank you so much for hosting us and for the opportunity to give this talk. And thank you all. So I can see cameras coming up. Are you sure you want to take this picture?
Yes, I want to see the cameras.
Unshare your screen.
Okay.
Okay.
Yes.
I look at.
Now,
congratulations on the great session.
Thank you.
Please turn on your cameras. Solomon Kojo-Hagan, I can see you. Implementation Committee Head.
Christiana, turn your screen to, oh, you've gone off. You should face the light. So turn your screen around and face the light. Oh.
Hussein, where are you? I can't find you.
There, he went off.
Hussein, is he there? Implementation Committee Head. Yeah, I've gotten the pictures. Thank you.
Oh, you've taken pictures already?
Yes, I've taken them.
Okay. Thank you. Okay, bye everyone.
Bye.
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 Bye.